Section 5, Video 3. Let's multiply fractions that have a little bit more simplifying that can take place. If we look at our first one, these are binomials. So our first step is to just take something out that they have in common, if they do. The first one we have a 5b squared in common. If I take 5b squared out, I'm left with b minus 10. The bottom one's b minus 1, that's okay. Next one's 2b plus 5, that's okay. Next, the denominator, however, has a 5b squared that can go into both those terms. If I factor that out, I get 2b plus 5. So we've replaced that and that. Now we can cancel vertically and diagonally. So instead of taking top times top here, or bottom times bottom and getting something more complex, it's always good to see if we can cancel things and make it simpler first, especially when we have binomials and trinomials involved. So if we look at this, we notice that 5b squared is present diagonally, so we can cancel those out. 2b plus 5 is present vertically, so we can cancel those two out. And we're left with a b minus 10 in the first fraction, a b minus 1 in the bottom of the first fraction, and basically just 1 over 1, because everything cancels out here. So we're left with b minus 10 over b minus 1. I cannot cancel the b's because, remember, these are implied parentheses and they're locked together. So this is done. A little more interesting question. We have binomials and trinomials here. So let's take a look at the first one. I guess we would all agree that if we tried to multiply top times top here and bottom times bottom, we would have quite a bit of work ahead of us to do all that distributing. So always a good idea to see if we can simplify first. So here we have a 10x squared that is a greatest common factor. If we take that out, we have 2x minus 7. The bottom one here I'm going to do last. So I'm going to go to the next fraction. On the bottom it's done. It's just x minus 2. On the top I can take a 3 out. If I take a 3 out, I'm left with x squared plus 13x plus 30. So I have a 3, and then we have a trinomial that we can now factor more easily. Plus plus is a plus plus. I'm going to factor here by trial and error, but I don't need to do that. I can just look at 30 and say what two numbers give me a product of 30 and a sum of a positive 13, and that's 10 and 3. So this isn't really guess and check. So that one's ready, so I rewrote that one. I rewrote this one. The next one, we also have a 3 in common, so if I take that out, I'm left with that. Now because of the 2 in front, this is x squared by the way, sorry. This one would take a little more work. But I'm going to do this one by factoring by guess and check. Let's see how it goes. First, just because of the space we have. I know the first two terms multiply together to give me 2x squared, so 2x times x is what I'll use. A minus minus is, based on the form in the guide notes we had earlier, tells us that in a trinomial, a minus minus gives us, in our binomial, a different set of signs. So I'm going to try 7 and 3 and see what I get. These two give us negative 6x. These two give us 7x. Together we get a positive x. But if you notice, we need a minus 1x. So I have to change their signs. So that means I'm going to have to go up here and change these signs backwards. So this becomes a plus and that becomes a minus. So that's factored. So I've now rewritten that one, and let's see if we can cancel. I have a 2x minus 7 here, and vertically I also have 1, so I can cancel that out. I have a 3 here, and diagonally I have another 3, so I can cancel that out. We have an x plus 3 here, and diagonally an x plus 3 there, so we can cancel that out. So that would leave us with 10x squared over 1, because everything canceled below. We have an x plus 10 and an x minus 2. So if you multiply top times top, I do not actually have to distribute, because this would be good enough for what we are expecting, and that would be considered finished. And this ends Section 5, Video 3.